So as we wrap up carboxylic acid derivatives, let's look at an example of a synthesis problem we could do. We have a 4-carbon alcohol, and I want you to take this 4-carbon alcohol to an amide. Work forward, think about the reactions you know of alcohols. Work backwards and think about the reactions you know that synthesize amides. Pause the video and think about some strategies. So as you think through a problem like this one, our reactions focused a lot on carboxylic acids and carboxylic acid derivatives. So whenever we see an alcohol in our synthesis, one of the things that we know how to do is convert that alcohol to a carboxylic acid. I could take this alcohol and I could treat it with KMNO4, I could treat it with chromium trioxide, I could treat it with sodium dichromate. I have 3 ways that I could oxidize this primary alcohol to a carboxylic acid. So one example is the Jones oxidation, CrO3, H2SO4, and water. The product of that reaction is my 4-carbon carboxylic acid. Now there's a lot of reactions that I know how to do with carboxylic acids, and there are a few ways that I know how to make amines. Keep in mind that you cannot take this carboxylic acid and just treat it with an amine Keep in mind that you cannot just take this carboxylic acid and treat it with an amine like ammonia in order to make the product. Because if you take a carboxylic acid and an amine, what you will do is an acid-base reaction where we will get the carboxylate ion and an ammonium ion, like so. So that's not a valid strategy for this problem. We know how to make amides from acid chlorides, anhydrides, esters. So any of those strategies would be valid here. So in one strategy, I could take this carboxylic acid, I could treat it with thionyl chloride and heat and make an acid chloride. From there, I could treat my acid chloride with 2 equivalents of ammonia in order to make that amide. As an alternative, I could take this carboxylic acid and I could treat it with P2O5, and that would allow me to make an anhydride. And then I could treat this anhydride with 2 equivalents of my amine in order to make the amide as well. You also could take the carboxylic acid and you could treat it with diazomethane or any of your other 2 reagents that allow you to make methyl esters. That would allow you to make the methyl ester. And from there, you could treat this with your amine in order to make the amide. Let's look at another synthesis example here. In this problem, we're starting with an alkyl halide and we want to make an ester. Specifically, our alkyl halide has 1, 2, 3, 4 carbons, and our ester has 1, 2, 3, 4, 5 carbons. So during the course of this reaction, we need to make a carbon-carbon bond. Think about the ways you know how to make carbon-carbon bonds. Think about all the ways you know how to make esters. Think about the reactions you know of alkyl halides. Pause the video and think about some synthetic strategies. The strategy that I'm going to use in this problem is the use of a nitrile functional group. It will introduce an additional carbon into my structure, and it will allow me to extend the length of that carbon chain by 1 carbon. And I can do that through an SN2 reaction. I can take this alkyl halide and I can treat it with sodium cyanide in DMSO, and I can do an SN2 reaction. My cyanide ion will attack at carbon number 1, displace that bromide, and I will make this compound. And remember that this compound has 1, 2, 3, 4, 5 carbons now. So when it comes to the reactions of nitriles, I know how to do a hydrogenation of a nitrile, and I know how to do a hydrolysis of a nitrile. So what I can do next in order to connect this nitrile and this ester is I could do a hydrolysis. So I'm going to take my nitrile under acidic conditions, and I'm going to treat it with a strong acid like HCl, water, and heat, and that's going to give me a 5-carbon carboxylic acid. Once I have this 5-carbon carboxylic acid, I need to convert this carboxylic acid to a methyl ester. There's 3 ways that I can convert a carboxylic acid to a methyl ester. Do you know what they are? The first way that I can convert a carboxylic acid to a methyl ester is by far the most general way to synthesize an ester, and that is the Fischer esterification. So that will require methanol, an acid like sulfuric acid, and heat. That reaction allows me to make any ester. Specifically for a methyl ester, I also have 2 other options. For this final step in my synthesis, I also have 2 other alternatives. I also could have chosen to treat my carboxylic acid with diazomethane. That will allow me to convert my carboxylic acid to my methyl ester. Or I could treat my carboxylic acid with a base like potassium carbonate and iodomethane. And that will first do a deprotonation of my carboxylic acid, followed by an SN2 reaction between that carboxylate ion and my iodomethane. Overall, there are 3 ways to convert a carboxylic acid to a methyl ester. And again, your Fischer esterification is the most general synthetic method that you have for that transformation. In another synthesis reaction, I could ask you to take 1-butanol in combination with sodium cyanide as your only carbon-containing sources for this reaction in order to make the amide shown. Now, because these are my only carbon-containing sources in this reaction, I know that in my sodium cyanide, I have a carbon-nitrogen bond. In my product, in the amide, I have 2 carbon-nitrogen bonds, so it's highly likely that at least one of those carbon-nitrogen bonds is going to come from my sodium cyanide molecule. So either this bond or this bond is going to come from my sodium cyanide. My sodium cyanide only introduces 1 carbon into my compound. And so if I look at my alcohol, I have 1, 2, 3, 4 carbons. So I have a chain of 4 carbons. And in my amide structure, I have 1, 2, 3, 4 carbons. So that means that those 4 carbons probably came from the alcohol. For the group that's bonded to my nitrogen, I have 1, 2, 3, 4, 5 carbons. So that if I think about how I'm going to bring these pieces together, it seems likely that my alcohol carbons are going to be where I get these 4 carbons in my molecule. It seems likely that the 4 carbons on the amide also would have come from a second molecule of that alcohol. So it appears to be that this carbon-nitrogen bond comes from that molecule of sodium cyanide. How would you put all these pieces together? Pause the video and come up with a strategy. So if I think about how this synthesis is going to come together, I'm going to need to bring an amine and another functional group together. So this amide could be made from an acid chloride and an amine, like this. I've got the 4 carbons in my acid chloride, and I've got 5 carbons in my amine. Now I have to figure out how to convert my 4-carbon alcohol to the 4-carbon acid chloride, and how to convert my 4-carbon alcohol in combination with the cyanide ion to my 5-carbon amine. So if I think first about how I'm going to take the alcohol and convert it to the acid chloride, I can take my alcohol and I can do an oxidation from a primary alcohol to a carboxylic acid using one of my 3 methods. I can use sodium dichromate with acid and water. I can use chromium trioxide with acid and water. I can also use KMNO4. Either way is fine. From there, I need to convert the carboxylic acid to the acid chloride. I can do that using PCl3 or thionyl chloride. I'll use PCl3 in this case. So overall, that gives me my first target, the acid chloride. Now I'm going to take my alcohol, and I need to react it with the cyanide ion in order to extend my carbon chain. And the cyanide ion is a good nucleophile in an SN2 reaction, so I need to convert my alcohol to a better leaving group. So I can treat my alcohol with PBr3 in order to convert the alcohol to the bromide. The bromide is a much better leaving group. Now I can treat this compound with sodium cyanide, DMSO, conditions that will favor an SN2 reaction, and I can extend the length of my carbon chain by 1 carbon. My carbon chain now has 1, 2, 3, 4, 5. So the current molecule that I'm working with has all of the carbons that I need in order to make this amine. It also has my carbon-nitrogen bond, which I need for the amine. So now what I need to do is I need to convert my nitrile to the amine. And I can do that through a hydrogenation with hydrogen gas and a platinum catalyst in order to make my 5-carbon amine. So now that gives me my second target in my synthesis. So now my synthesis will need to bring these 2 components together. So I'm going to take my acid chloride, I can bring in my amine that I just made, synthetically I can either use 2 equivalents of this amine in order to make my product, or this would be a good case to use triethylamine as a component in my reaction that will act as the base, so that all of this amine that I just synthesized gets converted to product. So I can run this with my 5-carbon amine. I can use triethylamine as my base in this reaction, so triethylamine will be present in an excess, and the product that I get out of this reaction is my amide. And this represents my final synthetic target.